Linear probabilistic modeling is a type of modeling in which the dependent variable will either take the value of 1 or 0, depending on whether the tested case succeeds or fails, meaning it yields whether some sort of tested expectation was met or not. This is also called a binary variable. Essentially, it will graph a function that shows us how the behavior of one event affects another. The LPM can be calculated through the following equation, where b0 is the intercept of the regression line, b1 is the slope, and epsilon is the random deviation. The equation below it represents how we calculate our expected value of a specific y given a value for x. But as we know, y can only hold 0 or 1. Simplifying the equation to, the probability of y being 1 at a given x is equal to the expected value for a certain y and a certain x. So, if our original equation represents a linear function, we know that at any given point x, our y will be b0 plus b1x plus epsilon. So, as x changes, our probability will change by a factor of b1. And if x is 0, b0 will represent our y outcome. That is the behavior in the case that there would be no deviation. A real-life example can be seen in sports. Take for example Neymar, who had a 220 million release clause that was paid from another team to sign the Brazilian, that now receives a 36.8 million euros salary. It sure makes us wonder how a player can be worth so much. And a big club like that should definitely look at the financial side of signing a player for that much money. In one case, where LPM would be useful, is by plotting whether the value of a signing equals to a larger amount of shirt sales. And by simple LPM, a club owner could realize that investing that much money in a player will surely bring more revenue through shirt sales to the club. The world of engineering may not be as simple as the world of sports. While in many cases there is no need for LPM to understand the correlation between two factors, there is an equal, if not bigger, amount of cases in which, had it not been for the modeling, perhaps a correlation would never have been drawn. Imagine a small company that does pool repairs. Being a local company, they have a limited budget for advertisement, so they must choose carefully when and where to use their money. But based on collected data, they realize that people tend to use pools mainly during specific months of the year, where it's hotter. So, they strategically concentrate most of their marketing to the weeks prior to the beginning of those months in order to convince their potential customers to touch up their pools before then. This correlation could be modeled by the LPM. Not only that, if they've done that for numerous years, they can then model a graph based on the months of the year in which people request the highest amount of pool services and advertise on the months that people don't.